how I ended up in mapping was actually through starting Mapillary. When we started, me and my co-founders, 5.5 years ago now, we didn't actually know anything about mapping, and none of us have a mapping background. But we came in through the idea of Mapillary and scaling up map data generation.
Hi, and welcome to another episode of the Mapscaping podcast. My name is Daniel, and this is a podcast for the mapping community. Today I'm talking to Jan, and Jan is the co-founder of a company called Mapillary. Now, Mapillary have created a platform that is rethinking the way we collect and distribute street-level data. It's a really big idea. We can all be a part of it, and I hope you enjoy the interview. Hi Jan, thank you so much for taking the time to talk to me today. I really appreciate it. And from the little bit of research I've done on you, it looks like you are a computer vision scientist and also a former math professor. How did you end up doing anything with maps?
Hi Daniel, it's great to be here on your podcast. Yes, that's right. I'm a computer vision person. I've been in computer vision since the 90s, and it's essentially all I've done my adult life. And yeah, well, so how I ended up in mapping was actually through starting Mapillary. When we started, me and my co-founders, 5.5 years ago now, we didn't actually know anything about mapping, and none of us have a mapping background. But we came in through the idea of Mapillary and scaling up map data generation. So that was the starting point. But my background is solidly as a math professor and as a computer vision researcher.
Now, before we dive into what Mapillary is, maybe you could just tell us how you came about the name. Where does the name come from?
So the name comes, it's a play on the word capillary. So the smallest blood vessels all the way out in your body. And so change the C to an M and then becomes mapillary, as in the ones that can map all of the roads all the way out to the smallest ends of the world.
Fantastic. Okay, so from that little bit
It's
that you
about
just
scalability in data collection, scalability in mapping. So it's a fun name, but not many people get the connection.
Oh, it makes perfect sense once you've explained it, of course. Okay.
Yeah.
So from that little bit that you've said about it, we know that the company that you founded is called Mapillary. We have a little bit of idea where the name came from. What is Mapillary?
So Mapillary is a platform that can take images from any camera, anywhere in the world. Anyone can contribute. And we take those images, we put them in a common representation, and we mine it for data using computer vision. And what that means is we can generate map features and publish them out the other end. So if you go to our website, you can access images, you can search for things that have been detected in images, and you can search for things that have been positioned as map features using computer vision. And that's the output of the platform.
Okay, and what problem are you solving with the output of this platform?
So the problem is really fundamentally map updates. So there's an increasing demand for more rapid updates, better coverage through a wide range of sectors. So mapping, but also cities, local governments need this, and more now also in automotive. And what we do is essentially, there are three things we bring. The first one is a scalable method for collecting images. So when we started Mapillary, the principle was any device. You could have any camera anywhere in the world, and we need to support it. So we support thousands of different devices. It's smartphones, action cameras, onboard vehicle cameras, professional rigs, anything you can think of, really. And that gives you scalability in the image collection, because right now, in this very moment, on every street that matters on the planet, there's someone there with the tools to collect the data needed for mapping. And the second thing is computer vision, and that's where my background comes in. And my co-founder Yubin, who was my PhD student once, what we do with the images is not only do we connect them together and reconstruct the world, but we also mine the images for information, and that helps remove a lot of the manual steps when you take imagery and you convert it to map data. And the third thing we do is that we publish this so that anyone can access it. And so and this was actually the key starting point with Mapillary. So we publish the imagery, we publish the data, and we give clear usage rights, what you can do with these images and with this data. And anyone can access it. And if you want a commercial license, it's the same license for everyone, same terms, same pricing. And that was the starting point, actually, understanding that no one else collects and shares the raw data, the raw building blocks used for mapping. So that was like 5.5 years ago when we started.
So just to make sure that I understand this, I'm sure the listeners are following along perfectly fine. It's just me. So you have a system where you can collect data from almost any device anywhere on the planet, as long as it's got some sort of image taking ability and can be uploaded to the cloud. And you process this data. So you segment it, you're looking for objects in there, and then you provide a database that anyone can access of these segmented images of the objects that you found and the images themselves. Is that correct?
Yes, that's correct.
So it sounds like, and I'm sure you get tired of this analogy or this comparison, that you're building the Google Street View for GIS users or for geospatial people.
Yeah, I mean, we often get compared to that, and it's a good comparison in one sense, and it's a tricky comparison in another sense. The thing is, like, imagery and collecting images is normally done with these mapping vans, like the Google Street View van. But if you look at the GIS and cities and how they solve their problems, like asset inventory and things like that, they use the same process. So they will go out and hire a mobile mapper to come drive this expensive van with expensive equipment in a completely unscalable way. And so the same tools and the same unscalable tools are used in both mapping and in GIS. And imagery is that fundamental component that helps you do asset inventory and all sorts of different things, keep maps updated. So the scalable way of collecting imagery applies to both of those. Where the difference comes in is Google Street View, if we want to mention that example, doesn't let you use the images outside of a Google map. You're not allowed to use the images to edit your map database or your asset database. You're not allowed to use it for anything, really. And that was the making Mapillary available with clear rights and letting you use it was again like one of the starting points behind this. Because I had friends that were doing, they were building different navigation apps, routing solutions. They were trying to build things that required raw data or imagery, and none of the mapping providers would provide it for them. There was no one willing to share that raw material. And that was the starting point of Mapillary, actually, seeing that we can actually collect this if we do it the right way. If we build the right platform with incentives inside the platform, we could actually do this and publish it and make it available. So that's like the difference is what you can do with the data, but the similarities is, same use cases.
Yeah, and also I'd argue one of the differences is the scalability of it. If you have everyone on the planet that has a phone in their pocket, if they can contribute to this data set, then this thing can scale up infinitely.
Yes, and the other silly thing is the collaborative approach, right? Like we're always pushing this model of it's better to collect images together. So you have the citizens, you have the city, you have all of the commercial actors in the city that are now helping each other by being on the same platform. Whereas, for example, here where I'm sitting right now in Malmö, Sweden, I know at least 4 different mapping companies and mobile mappers have driven all of the streets of my town with high-resolution cameras, but I can't see any of them. And it's just an unscalable and expensive way of doing it, because these are updated then every 4 to 5 years, instead of just pooling together and continuously collecting data that everyone can use. So the collaborative approach adds another element of scalability because you're not the only one contributing data.
And we've also seen this approach in OpenStreetMap, and that's been incredibly successful. So it's definitely a viable option. There's no question about that. Maybe you could just take the time to walk us through what the customer journey or the user journey would look like. Okay, so I'm walking down the street. I have a phone in my pocket. I take out my phone. What happens next?
Yep. So the easiest way to contribute is to use our smartphone app for iOS or Android. So you would have the app on your phone. You start it, you open the camera view, and you click the start recording button. Then the app will take images automatically as you move around, sample based on distance as you're moving. And when you get to Wi-Fi, it will upload the images automatically to Mapillary, where we process the images immediately as they come in. And then all of the understanding and data generated from those images is immediately available in all third-party integrations that use Mapillary somehow downstream. But for you as a contributor, it really is start and stop in the app. That's all you need to do.
Okay, that answers a whole lot of questions, because I was just imagining I could use my normal phone app, my normal photo app on my phone, but you have your own app. So I guess that provides you with a whole bunch of different data. I'm assuming location is very important, and time, for example. If I was going to build a database like this, I'd be really interested in having those two features. Is there anything else that app is collecting, or that's really, in terms of data, that's really important for the post-processing of these images?
No, that's a great question. And actually, I should mention, so when we say any camera, the minimum requirement is that there's an image, there's a timestamp, and a rough location given by a GPS in your phone, for example. And so that's the minimum requirement. You can use an external GPS, you can use 360 cameras, you can use videos, whatever you want, but time and location needs to be there for us to process it properly. But yes, using our apps is by far the easiest way to collect. One common, very easy way to do it is you request a car mount from our website, and you put it in the front window of your car, and then whenever you drive somewhere interesting, you just put up the phone and you start recording. So it's actually very, very easy to do it that way.
Like, I'm a map geek myself, and I love the idea that I can contribute to something like this. I love the idea that I can make a difference, that I could improve this data set and somehow make the world a better place. So that's fantastic. What's the next step? So the data or this video is arriving at your server, whenever we bump into a Wi-Fi connection again. And then you segment the data somehow, or what happens then?
Yep. So that's where the computer vision kicks in, and so we run a range of things on the images, starting with privacy blurring. So we blur faces, we blur license plates in all images, and then we run segmentation. So we label all the pixels in all the images. Our current production system does 97 different unique classes. So we know what's where in the image, and then we run traffic sign recognition, where we do it currently in 100 countries. So we have 1,500 unique signs in 100 countries that are being automatically indexed and labeled. And then, because the way we connect the images is that we build a 3D model of every location where someone takes pictures. So if you walk down the street, take pictures, I drive down the same street a week later, the way we connect your images with my images is by building a 3D model and putting them in the same coordinate system. But by building that 3D model, we can also take the things that we find in the images and position them and give them their own latitude and longitude. And then they become map features. So for things that we recognize, that we label with segmentation or with the traffic sign recognition, things that are stationary, we can then triangulate and position. So we remove cars and pedestrians and bikes and things that are not stationary. The other things, if we see them in more than one image, we can then also position and give them their own latitude and longitude, and then they become map features.
That's really interesting. In terms of the segmentation, I know that on the internet, for example, you go to a website and they want to prove that you're not a robot. So they show you a whole bunch of pictures of cars or traffic signs, and
Yeah.
you have to, and you're doing segmentation there. As I understand it, you're telling the computer, hey, this is a picture of a car. This is a picture of a car. That's not a picture of a car. So you're giving this computer a whole bunch of information that can work with, and it can take that out and use that in the real world, for identifying cars. Is that how you've done it? Have you had people manually identifying street signs, or does your software solve this problem by itself?
Well, so the software runs by itself, but there is actually because it's also we have crowd moderation and crowd editing on the platform too. So if you see something that you don't like, if there's an image that shouldn't be on the platform, or if there's something that should be blurred in an image, you can go in and fix that. But you can also go in and validate or correct the machine generated detection. So and there's a tool for that actually, where people who need their data verified, because we generate machine generated data. So you can go in and say, show me all of the speed limits in California, for example. And we'll show them to you on a map, or you can download them through our API. But and they're machine generated, but if you want them validated so that you know that they're 100% correct, there's also a tool for doing that on the website. So we use human interactions as a way of cleaning up data sometimes, but not so much for training the algorithms.
Okay, so now we've captured our data, we've segmented it, and now that the output is data. The output is this database. We talked a little bit about it just before, where we have a whole bunch of machine-generated data, and then we can have manually verified data. What other things come out of this, or what's in the database? Can I expect to find a whole bunch of positions of road signs or shop fronts or cars?
Yes, all of that actually. So the three outputs, like technically speaking, the three outputs from the platform is the first is imagery in this consistent 3D representation. So most, if not all, of the downstream integrations from the platform use our open source viewer Mapillary.js, which lets you move around and explore places using this 3D information. So you can look at an image, it's taken by a smartphone. We have other images nearby, and if you want to move left or right or forward, we compute that, and you can move around and explore. So imagery is one, and you could use that by to go in and do like a visual inspection of a location, or track changes, or building permits, or checking that people are doing the right thing in a certain area, like visually looking at it. The second thing you can get is exactly from this labeling of the images. So we index every pixel in every image in every location on the planet. And so you can go in and search for things. So show me images of bike lanes in Copenhagen, for example. And you will see on the map all of the images where we have found bike lanes in Copenhagen. And then you can visually look at that and solve some kind of problem. The third is you can get these map features, which are the things that are positioned. And you could say, for example, show me all of the traffic signs of this type in this location, and you will see them on a map, or you'll get it through the API. So technically speaking, those are the three things that you can get from the platform.
So obviously you're solving the data capture problem. You can capture data at scale, you can segment it, and you can distribute it. So that's the umbrella problem, as I see it anyway, that you're solving. Can you give us an idea of some of the more precise use cases where you see this being deployed?
Yeah, of course. So you can use it for anything you like, as long as it's not a military application. You can use the platform for whatever you like. But we have three main buckets where usage is. And the first one is in mapping. So it's either mapping and creating a map in areas where you don't have coverage from before, or it's updating your map, or it's fixing issues reported to you as a map provider. So if someone goes in and complains and says, actually, I'm not allowed to turn left in this intersection, hey, map provider, you need to fix that, or this intersection is now a roundabout, you guys need to update your map. Unless they have an image, or unless they have some data to validate that, they can't actually fix those issues, right? And the bigger mapping providers get a lot of issues reported all the time. And so using imagery, you can go in and say, okay, great. And they resolve the issue with the help of the images, for example. Let's see, what else? Well, turn restrictions, one-way streets, things like that, speed limits are useful for updating properties of navigation and routing systems. So that's mapping. The second category, GIS, where the most common case is different types of asset inventory. So if you think about any object in the street scene as you're walking around your city, usually someone is responsible for maintaining and keeping those things up to date. And so they could be signs, it could be potholes or road surface, it could be different utility poles or whatever it is. And so in that case, we actually both give them the tools to go out and collect imagery easily, for example, with our smartphone. And then they can get the data and the location of all their signs or utility poles or whatever it is that they need to check. And we automate a big part of that manual work of doing asset inventory. And then the third customer segment is automotive and automotive mapping, where some problems are similar to traditional mapping. You just need to update and flag issues that need to be fixed. But in the automotive side, we're also seeing people use Mapillary because we index these images all over the world. We're seeing them using Mapillary as a source of training perception algorithms. So to understand, for example, what pedestrians look like in different countries, or what signs look like in different countries, for example.
That last use case, that was something I was personally interested in, because when I was saying that, cruising around the internet, often you get asked, "Are you a robot?" and you have to prove that you're not a robot. And I thought when I heard you talk about that database that you provide or are creating and updating, I thought, wow, that would be an amazing training set. So hopefully, no longer will we be asked if we're robots or have to identify cars. Hopefully, they can just point their robots at you and figure it out.
Yeah, it is actually, and when you think about it, sort of the variability of types of cameras, types of viewpoints, and just the scale of image collection is very, very hard to do on your own. If you're even if you're an automotive company with a fleet of vehicles, sometimes you have to drive many miles before a certain type of thing happens, and we already have that indexed. And we have it in many countries. So it's a very interesting database, actually, for understanding what things look like around the world.
There's no doubt, not that I've seen the database, but just hearing you talk about it, like there's no doubt in my mind that it's an incredibly interesting database, an amazing resource, especially if you keep maintaining it. In 10 years' time, 20 years' time, it'll be something incredible. A huge amount of data will be in there for sure. We've talked a lot about capturing data from a road. We talked about having that camera in the dash. We were driving down the road, constantly recording things, uploading. We talked about street signs. We talked about cars. Again, if we come back, I apologize here, if we come back to our Google Street View example, we've seen examples of people hiking trails and mapping the entire trail. Is Mapillary, is it something that will always just be focused on roads, or could you take it out into the wild?
Yeah, you can actually do that, and that was one of another of the core founding principles of Mapillary is anyone should be able to do it, but they should also be able to do it anywhere they like, to go wherever they feel is valuable. And so we actually have people mapping. We have lots of hiking trails. We have lots of bike paths, the type you see in Europe, where the bike path actually goes somewhere completely different than where the roads go. And we even have people mapping rivers and sort of go out with an action camera on their kayak and they map rivers that way. You can go anywhere you like. And we usually just say any place that matters to you, you can go and map it. It doesn't matter. We'll run the same algorithms. We're going to publish the images. We're going to publish the data just as if you're capturing on a road.
So let's say I'm walking a trail. Will that mean then that your algorithms are looking for different things, or are they looking for the same thing regardless of what information's coming in? Because I'm thinking like segmenting for cars or road signs where I'm nowhere near a road. I'm wondering if that would make sense.
Yeah, so we run it's the same object classes. And of course, it's trained more on street scenes than not. But it works in many strange scenarios where you think that it wouldn't. So, for example, there's a community of people mapping from trains. So they'll put cameras they'll ask the driver if they can put an action camera or a phone in the front window of the train, and they'll map train routes. And the segmentation and the object recognition actually works really, really well for trains. On hiking trails, or like if you're in the middle of a lake or a river, the segmentation gets confused sometimes. But luckily, we don't find too many traffic signs in the middle of a river.
But it's funny. One of my other questions was going to be, sorry, what was the most surprising use case for you, that you'd seen so far for your platform? But you might just have answered it there with people mapping from trains.
Yeah, it's well, I can understand it, right? I can understand why there's a geek culture around trains, and I can see mapping certain train rides around the world would be interesting. I go in and look at the pictures sometimes too. It's fascinating.
Yeah, and we're coming to the end of our time together, but before we say goodbye, I just got a few more questions for you. And I want to talk about OpenStreetMap for a second. OpenStreetMap has millions of
Yep.
edits every day, mostly done by humans, manually uploading new objects and correcting existing objects. At the same time, we had Bing or Microsoft that just released a complete building layer for the US, which was derived from segmented imagery, like what you're doing. Are we moving
Yep.
towards a future where we no longer see manual edits in maps?
So OpenStreetMap is a fantastic project, and the tradition and the mode of editing has always been human edits so far. And we're seeing the start of a new phase where a lot of the edits prepared for these humans is actually done using algorithms. So Facebook has a lot of great work done on finding roads and buildings in developing countries for building sort of the fundamental basic infrastructure on OpenStreetMap in those areas. Bing did this exactly with from satellite imagery. Mapillary is doing it from street level imagery. We provide all of our images and all of our data for OpenStreetMap as well. And all of those sources, they create data machine generated at a scale that no human could ever do. So it is interesting to see how much machine generated edits are going to be accepted going into the future. Right now, it's still edits or data proposed through algorithms, but then humans actually, editors sit there and add it. At some point, that's not going to scale either, and it will be interesting to see how that's handled by the community.
Yeah, absolutely, because there's a really strong culture about that. People have invested a lot of time and effort into editing that map, and they feel a part of it. They're involved in it. And I think probably that's why
Yeah.
OpenStreetMap
Yes.
and many other projects in the same sort of area have survived, is because of that real culture around it. But yeah, I'm sure too that our increasing demand for accurate data and updated data is probably going to push up against a pretty hard wall there, and it'll be interesting to see how the community reacts.
Yeah, and they might accept it and embrace it. There might be some kind of fork where there's an additional data set that hasn't been validated by humans, but it's still open under the same license, and you can pick and choose. I don't know. It will be interesting to see what happens.
When is your technology, when is Mapillary not the right tool for the job?
When you go indoor.
Okay. Is that because of the segmentation algorithm, or is that because it's really hard to position or accurately position inside?
It's primarily for positioning. So the thing is, as soon as you lose your GPS signal, if you walk too far into a building, then it becomes really hard to do this. Just click and it will just magically work, right? Start the camera and it will work. Because then you need to have other means of localizing and figuring out where the image was taken. And we rely on at least a rough GPS position to figure out what images to match your images to, etc. And that doesn't work indoor. And the if you're in a multi-story building, it's even worse. How can we know if you're on the 4th or the 14th floor in a building without you telling us? So it's not an automatically working experience when you're indoor. So we try not to do it. We have some people that map train stations and things like that, but they go in and check and maybe edit and move some images afterwards because the GPS was not reliable. So I would say indoor is the part that doesn't work.
And what is the most exciting thing that you're working on right now?
So the most exciting thing, I think, is figuring out how to scale this up even more. So the tools and the platform, like the tools for collecting imagery, we have that. We have the platform that can make sense of the images, generate map data, and publish it. But how can we accelerate this? And how can we get people to collect data where it's needed, when it's needed? And so we just launched 2 weeks ago. We launched the Mapillary Marketplace, which is our first iteration in this, trying to connect the supply and demand sides of our platform, because we sort of sit in the middle, right? Like we get images in one end, and we publish images and data out the other end. But the people who need data in a specific region until now, they didn't have the means of connecting to the contributor network that could help them get that data. So if we can do a good job connecting those two sides, we're going to accelerate the growth and the mapping of the world, but we're also going to prioritize areas where people need help right now. And I think that's super interesting.
Jan, I really, really want to thank you for taking the time to talk to me today. It's been an absolute pleasure. I've learned a lot. I know my audience has learned a lot. But before we say goodbye, where can we go to learn more about you?
Best place would be to go to mapillary.com.
Excellent. Thank you so much for your time. Really appreciate it.
Thank you, Daniel.
And that's it for another episode of the Mapscaping podcast. My name is Daniel, and I really want to thank you for tuning in again this week and remind you that you are more than welcome to reach out to me on social media at Mapscaping on Facebook and Instagram and Twitter. If you have any questions or comments, I'd love to hear from you. I'd also like to ask you for a small favor. If you have a friend that might enjoy these episodes, please share it with them. I'd really appreciate it. Cheers. Bye.